Okay. Now the question number 21 from your textbook, Unsolved Numerical. A 20 centimeter wide thin circular disc of mass 200 gram. Suppose this is the disc. It is 20 centimeter wide. So what is given to us? The diameter is given to us, that is 20 centimeter. Then we have mass of the disc, that is 200 gram. After that is suspended to a rigid support from a thin metallic string. By holding the rim of the disc, the string is twisted through 60 degree. The theta is given to us 60 degree and release. If now it now performs angular oscillations of period 1 second, we have t, that is 1 second. Now calculate the maximum torque given generated in the string under undamped condition, and we have also given that pi raised to 3 is similar to 31. So what we need to find? We need to find is that maximum restoring torque, that is tau, and we need this maximum. So for a metallic disc suspended through a string, we have a formula for tau, that is c theta in magnitude form. C theta will not be considering the minus sign over here. So we have theta with us. We need c. We need the value of c. Okay. Now for c we can see another formulas. We also know that is t is equal to 2 pi upon omega. For this metallic disc suspended from a thin string, we have the value of omega, that is, see on page number 125 of your textbook we have this equation, that is angular acceleration is minus, will not be taking minus n, everything is in magnitude. So alpha is equal to theta, c theta upon I. We have this with us. Let's write that. Alpha is equal to c theta upon I. And what else we have? We also have, for this metallic disc tied to a string, we also have the formula for time period, that is 2 pi upon omega, and omega is nothing but under root angular acceleration upon angular displacement, that is alpha upon theta. So I can write here 2 pi upon, at place of omega I can write alpha upon theta. But what is alpha? Alpha is c theta upon I. So I'll be substituting there 2 pi upon alpha as c theta upon I, and this theta. So this theta gets cancelled, and I have t as 2 pi under root c upon I. So now comparing this equation with this equation, 2 pi is 2 pi, and at place of omega, what I have at place of omega, that is under root c upon I. So now I have the formula for omega, that is under root c upon I. Okay. Now what else I can do for omega? Yes, from this equation I can write, I want to find this. From this equation I can write omega is nothing but 2 pi upon capital T, right? So here I have the value of capital T, that is 1 second. So what will be my omega? Omega will be just 2 pi radians per second. Chalo, I have obtained my omega. After this, so in this I have obtained omega. Now I want this I. If I get the value of I, that is moment of inertia, by just making things easier, we can get c, and then I'll substitute that value of c over here and theta, and I can get tau. So let's see moment of inertia for a thin circular disc. So moment of inertia for thin circular disc is nothing but 1 upon 2 mr square. Now I will be converting these terms into SI unit. Okay, so 20 into 10 raised to minus 2 meter, 200 gram will be 200 into 10 raised to minus 3 kilogram. Okay, okay, now I have diameter. Where should I write? Right over here. Diameter. What about radius? Radius is just half of diameter, right? Half of diameter. Diameter is 20 into 10 raised to minus 2 upon 2. So it will be 10, right? Right. 2 and 10. So radius is 10 into 10 raised to minus 2 meter. This is my radius. What about mass? Yes, I have mass. I have just taken here capital M. You can do the changes in the given. Let this be as capital M. That doesn't make any sense. You can do the changes. Okay. Now, half capital M is 200 into 10 raised to minus 3 into radius square of my radius. My radius is 10 into 10 raised to minus 2 the whole square. Chalo. Now next step, let me cancel this 100. Now what all things I have? 100 into 10 raised to minus 3, 10 into 10 will give me again 100, and 10 raised to minus 2 and 10 raised to minus 2. So 100 into, this is all 1 1 2 3 4 4 zeros, right? And here I have 10 raised to minus 3, and here I have 10 raised to minus 4. 10 raised to minus 4, and this gets cancelled. So moment of inertia is nothing but 10 raised to minus 3, mass is in kilogram, and radius is in meter. So kilogram meter square is my moment of inertia. Okay, now I will be 10 raised to minus 3 kilogram meter square is my moment of inertia. Now it's easy. I'll be substituting moment of inertia value of omega, and I'll get the value of c. That is omega under root c upon I. I'll take the square root on this side, so this becomes omega square c upon I. I'll take it towards left hand side, so it is omega square I is equal to c. What is omega square which we have obtained? Omega square is nothing but 2 pi. So 2 pi the whole square, and my moment of inertia, that is 10 raised to minus 3. So 10 raised to minus 3, this is my constant. So let's 2 2s are 4, pi square into 10 raised to minus 3 Newton meter is equal to c. We have obtained c. Now it is very easy. I need tau, that is maximum. So maximum torque is nothing but c into theta. C is 4 pi square into 10 raised to minus 3, and theta is 60 degree, which is nothing but 60 degree is nothing but pi upon 3. Now I want this degree in radians. So how we got, why we are taking it as pi upon 3, not as directly 60, because it is in degree, and I want this degree to get converted into radians. So I'll multiply it by 1 upon pi upon 180. 0 0 gets cancelled. 6 1s are 6 3s are. So there is 60 degree in radian format, that is pi upon 3 radian. So after that, okay, 4 pi square becomes pi cube, 10 raised to minus 3, and I have 3 in the denominator. Let's do 3 1s are 3, 1 remains point, it becomes 10, 3 3s are 9, 3 3s are 9, 3 3s are 9, it continues. So it is 1.333 into, what is pi cube? In the question it is asked, not asked, it is suggested to take pi cube as 31. So we'll take pi cube as 31 into 10 raised to minus 3 Newton meter. Okay, now we will just multiply this and into 10 raised to minus 3. So I have multiplied and I have obtained this. After point I have 3 digits, so from here we'll start 1 2 3. Here it is, that is 41.323 into 10 raised to minus 3 Newton meter. 10 raised to minus 3 means the point will get shifted towards negative side. So 1 2, and just I'll be adding a 0 so that it becomes comfortable for us. You'll be doing this with pencil, no one is going to write this, okay? you'll just write the 0 in pencils. So 1 digit, 2 digit and 3 digit. So our point will be 0.04132 Newton meter. Hope you understood how I have shifted the point. 3 2 3 okay, this is the answer, that is maximum torque. Okay, the next numerical is numerical number 18 of unsolved numerical of your textbook. The period of oscillation of a body of mass m1. Okay, now here we have mass as m1 suspended from a light string. Okay, it is suspended, a body m1 is suspended from a light string. Suppose this is the light string and here this is the body of mass m1, and the period of its oscillation of this body is t. Okay, so the period of this body is t. After that, when a body of mass m2 is tied to the first body, now to this first body, a body of mass m2, suppose a body of mass m2 is tied to the body here. So, and the system is made to oscillate, the period is 2t. When we have two bodies with us, then the time period is 2t. Okay, we have two bodies, so m2 plus m1. When we have two bodies and it is oscillating, then the time period is 2t. When I had this one body m1, then the time period was t. Compare mass m1 and m2. I need the comparison m1 and m2. So let's start. Since we have t with us, we'll start with the formula of time period, that is 2 pi upon omega. Now we don't have anything else over here, just we have mass. So we'll try to get the omega in terms of mass. We all know m omega square is equal to k. So omega square will be k upon m and omega will be under root k upon m, right? So we'll take that t is equal to 2 pi, omega is as k upon m. So here we have the formula with which we'll be calculating or finding the comparison between mass m1 and m2. So sure, let's see. T is equal to 2 pi. If I write it in this format, this denominator, when it will go in numerator, it will just flip, so it will be m upon k. Okay, now this is for t, the mass is m1. And what about spring constant? Since the spring is same, k will remain as it is. Then for next system, it is 2t. Time period is 2t, 2 pi under root k. What about the mass? Here the mass is m2 plus m1, so it will be m2 plus m1. We'll write it in the same format. This will be written as 2 pi m2 plus m1 upon k. Hope you understood till here. We have just taken this formula and from which we have derived these two formulas, right? See, for time period t, we have mass as m1, we have mass as m1, okay, and spring constant will be same for both the systems, so spring constant is going to be just k. Then the time period, okay, here the time period for another system is 2t, so I have written 2t, 2 pi as it is. Okay, I think you all got confused over here, so to make things a bit better, just see what I'll do. Okay, what I have done, this is the formula of time period, that is t is equal to 2 pi upon omega. From omega we obtain this, that is under root k upon m, right? Then I am taking this term in the numerator, so this is the general expression. This is the general expression from which we are going to derive our expression for two systems. Okay, first system is the system in which we have just our mass m1. Okay, on second system we have two masses. Spring constant will be same because the spring is same. time period for this is t, and for this system it is 2t. So we will be deriving two formulas from this. So let's see for my first system what it will be. Time period is t, so this t will be as it is. Then it is 2 pi under root mass. For here mass is m1 upon k. Okay, understood? This is my time period equation for first system. Coming to second system. Second system, at place of time period it is 2t, so I have substituted 2t is equal to 2 pi. Okay, now look at this. At time period it is 2t, 2 pi, mass. We have two masses, so I have written here two masses, m, mass. So I have written here two masses and force constant as it is. Now you understood we have two equations from this general equation. Okay, hope the things are easy to you now. We'll be just dividing these two equations, that is t is equal to 2 pi under root m1 upon k upon 2t under root 2 pi under root m2 plus m1 upon k. After this, your t gets cancelled, your 2 pi gets cancelled, k gets cancelled. So what remains is 1 upon 2 is equal to under root m1 upon here under root m2 plus m1, right? Both of them are in square root form, so I'll write a common square root. That is 1 upon 2 common square root, and my m1 m2 plus m1. I'll be taking square root on this side, so it will become square, and here I'll have m1 m1 plus m2 plus m1. So 1 1s are 1, 2 2s are 4, that is m1 m2 plus m1. Cross multiply m2 plus m1 and this 4 on this side, so that becomes 4m1. So I'll keep this m2 over here and take this m1 on right hand side, so we have 4m1, and this positive comes over here, becomes negative, so m2 is nothing but 3m1. So this is the comparison which we have obtained, or else we can also, this is the answer, you can leave the answer over here, or you can also write let m1 be over here, take m2 in the denominator, what remains on this side, nothing, and then the 3 goes over here. This is also the answer. Okay, so this is the comparison which so our next numerical is 23 from your textbook. And what the question says, most of the time what happens, after seeing the size of the question, the students usually think it is the difficult one, we are not going to attempt it, or we will not be able to attempt it. But students, don't go on the size of the question, just read and understand the question. Try to read and understand it. Okay, now a wooden block of mass m. So here mass of the block is given to us, that is m, is kept on a piston. This is the piston, a wooden block. Let me make a wooden block. This is the wooden block of mass m which is kept on the piston. What is given is piston that can perform vertical vibrations of adjustable frequency and amplitude. We can adjust the frequency and amplitude of this piston, which performs vertical vibrations. Means if this is the mean position, it will go upward and downward. So these are vertical vibrations. During vibrations, we don't want the block to leave the contact with the piston. This is the condition. During these vibrations, this block should be with the piston. Their contact should not lose, or should not leave the contact. How much maximum frequency is possible? Okay, we want here frequency. If the amplitude of the vibrations, this is the amplitude, means maximum displacement from the mean position is the amplitude, is restricted to just 25 centimeter. We have amplitude that is 25 centimeter. Okay, then what else we have? In this case, how much is the energy per unit mass? Energy per unit mass of the block. we have this given to us, that is G is approximately equal to pi square, which is approximately equal to 10 meter per second square. Okay, chalo, let's start. What we need to know that which force will try to bring the piston, if the piston is at this position, at the highest position, which force will trying to bring the piston to its equilibrium position? Restoring force. Okay, so restoring force is given by formula F is equal to kx. We'll consider magnitude of the restoring force, no negative sign. Okay, now here at place of displacement we'll take amplitude. So F is equal to, because what is amplitude? Maximum displacement from the mean position. So here we have this formulas. What is K? M omega square. Sure, we can write at place as m omega square and a. What is force? Mass into acceleration. But here the force on the block and on the piston will be always in the downward direction, and that will be according to the weight of the block. What is the condition given to us? During vibrations, we don't want the block to leave the contact. We don't want the block to leave the contact. So wherever is my piston, at the highest point, or this will be the lowest point, this is the mean position. At the highest point, piston, if the piston is over here at the highest point, or the piston is at the lowest point, weight will be of course in the downward direction, right? So force will be according to the weight, right? Whatever will be the restoring force, that will be according to the weight of the body. If the body is light in weight, that much will be the restoring force applied to the body to bring it to the equilibrium position. अगर हल्की बॉडी है तो हल्का restoring force लगेगा उसको अपने ओरिजिनल जगह पे लेके जाने के लिए. अगर बॉडी हैवी है वेट में, मतलब restoring force is always according to the weight of the body. So here I'll write mg over here at place of the force. Then I can cancel this m. So what I have? G is equal to omega square. I'll write this a over here. So I can write it like this. Omega is under root G upon A. Now, why we want this? We want frequency. What is the formula for frequency? Frequency is nothing but 1 upon T, right? So 1 upon T is what? T is nothing but 2 pi upon omega. So this is omega upon 2 pi. So to find out the frequency, we need omega. Okay. So now let's do substitutions. What is G approximately? 10. And what is A? It is 25 centimeter. We'll convert it into meter. So it will be 25 into 10 raised to minus 2 meter. So here it will be 25 into 10 raised to minus 2. And here I have omega. This 10 as it is, 25, and I'll take this 10 raised to minus 2 in the numerator. 10 raised to minus 2 is nothing but 100. As it goes in the numerator, it becomes positive. So I'll remove them outside the bracket. 100 outside the square root, that is 10. 25 is 5, and under root of 10. What is square root of 10? See, square root of 10 is 3.162. So omega is, let me see, it is 10 upon 5, 10 upon 5 and 3.162. Then 5 ones are 5 zeros are 0, so it becomes 31. 5 6 are 30, 5 3s are 15, 5 6 are 12. No, 5 2s are 10. We have, because of point, that becomes 20. 5 4s are 20. So it is 10 into 0.6324. Because of 10, point will get shifted, so it is 6.324 radian per second. Now we need to find n. N is nothing but omega upon 2 pi. Omega is 6.324 upon 2 pi, that is 6.324 to 6.324. 2 into pi is 3.142. Will multiply. 2 2s are 4, 2 4s are 8, 2 1s are 2, 0.23s are 6. See, there are many ways to solve. If you are good in multiplication, you can do this step, or the next step can be this. You can just divide. 2 3s are 6, 2 1s are 2, 2 6 are 12, 2 2s are 4. So the number will be 3.162 upon 3.142. So chalo, we'll not do with this method, we'll go with this. In this method, it is same. Ultimately, we are going on log and anti-log. If you are just multiplying, then you will be applying log over here, and if you are dividing by 2, you will be applying log over here. So I'll be going with this one. So log of 3.16 will be getting the same answer. So log of 3, you all can just do and check. 0, we have just one digit, so 1 minus 1 0, 31, 6 2. We'll check. Minus, we have just one digit, so 1 minus 1 0, and we'll check the log for this digit. So after checking the log, I got this as 5000, and for this it is 4972. Then subtracting 0.5, this is which is difficult from student's point of view. 4, 10, this becomes 9, 10, this becomes 9 and 10. 10 minus 2 is 8, 9 minus 7, 2, 9 minus 9, 0, 4 minus 4, 0 and 0. So anti-log of 0.0028. Okay, let's see the anti-log of 0.0028. That is 0.002 and 8, that is 2, and here it is 1.005 plus 2, that is 1.007. So it will be 1.007, and since we have 0, okay, sorry, it will be 1.007, and since we have 0 over here, that will be 10 raised to 0. 10 raised to 0 is nothing but 1, so it is 1.007, which is approximately equal to 1 Hertz. This is the maximum frequency. Okay, maximum frequency. After that, what is next, which is asked to you, that is energy per unit mass. We know the formula of energy is half Ka square. This is the formula of energy. Wait, I'll show it to you in the see, the formula for energy on page number 121. Energy is half Ka square. So we'll be using that, half Ka square. What is K? M omega square, right? So we'll be substituting half m omega square and a square. We'll do the calculation and then we'll get the value of energy per unit mass. Okay, now what is asked to me? Energy per unit mass is asked to us, है ना? So this is the formula for energy, that is half Ka square. So what will be the formula for energy per unit mass? So what remains over here? Half, if m goes in the denominator in left hand side, what remains? Half omega square A square. So this is the reason why you should read the question and understand what is asked. Till now anything was difficult to you? No, nothing was difficult. We just kept on writing the formulas and substituting and a bit of calculations. Half omega square a square. So E upon M half omega square a square. What is omega? That we have obtained. Omega is nothing but 6.324 square and sorry a square of the amplitude. What is amplitude? 25 into 10 raised to minus 2. Square of that 25 into 10 raised to minus 2 square of this. So we'll just do it quickly. 6.324 as it is, 25, that becomes 625 and 10 raised to minus 4, right? Okay, square. Then what next? Next can be, okay, now again you'll have to apply log in this. We can go by another way also. Either you all can apply log or we can go by another method, that is 25 into 10 raised to minus 2 here square. Here what we have? Omega square, right? Omega square. Omega. So what we have obtained for omega? For omega we have obtained it as 6.324. Let's go a bit upper. What it is? 10 upon 5 into 10 into 0.6324. Let's go a bit behind. From where did I get this? From here. 10 into under root 10 upon 5. I just substitute the value of 10 under root 10, that is 3.162, and I did the cancellation. So I have also got omega as 10 upon 5 into under root 10. I can use this omega over here. Instead of using direct value of omega, I can use this step and write it over there just to make our calculation easy. I will be writing 10 upon 5 under root 10. 10 upon 5 under root 10 and square of this. Students, if you are finding it difficult, you can just apply log over here and you will get the answer. Let 10 raised to minus 4 be out of the log. You have to just apply log and log. This minus 2 will, this 2 is in denominator, so this will become minus 2 and nothing else. You can apply log over here, or you can just, instead of taking value of omega, you can go at this step and take this value of omega, so that our calculation becomes easy. So 10 into 10, 100, under root 10, square root of 10. Square root of 10 into square root of 10 is 10. 5 5s are 25. Now here we have 25 into 25 and 10 raised to minus 2 becomes 10 raised to minus 4, right? So 125 from here, 125 from here, 2 1s are 2 5s are 10. Yes. 5 into 125 is nothing but 125, and this 2 zeros and into 10 raised to minus 4 gives me energy per unit mass, right? Joule. Energy is obtained in joule, and since I have mass, so joule per kilogram. So 10 raised to minus 4, suppose the point is over here, so 1 2 3 4, it will be 1.25 joule per kilogram. Now see, this is easy as compared to this. Hope you understood. Okay, the next question is question number 17 from your textbook, from Unsolved Numerical. Okay, a particle performing linear SHM of period 2 seconds. A particle is performing linear SHM, this is the mean position, okay, of period 2 seconds. So the time period is 2 seconds. It takes 2 seconds to complete one oscillations about the mean position. Suppose O is the mean position, and it is observed to have a speed of b under root 3 meter per second. Okay, speed of b under root 3 meter per second when at a distance b meter from O. Okay, from O it is at, suppose where should I take it? Suppose over here. at this position means this b meter at this position, velocity is b under root 3 meter per second. This is the velocity at this point. Okay. If the particle is moving away from O, okay, it shows my particle is moving at this side, away from O. Let's take it towards positive side only. At that instant, okay, at that time, find the time required by the particle. If the particle is moving over here at this side, at that time, okay, I want to find out that time. Find the time. At that time, what happens? Find the time required by the particle to travel a further b distance. This is b. From here to further b means still here. It is not looking equal, but you think it is equal. Okay. To this b, how much will be the time required to travel from this location to this location? How much will be my time required? Okay, that is the question. Now I'll just try to expand it so that it becomes easy to you. This is O. This distance is b distance, and till here it reached in time t1. Another b distance, another b distance. So how much time will it require? That is asked. And from here till here, suppose it is reaching in time t2. From here, from mean to this position, it reached in time t1. So from here till here, it will reach in time t2. So how will I get this time? Of course, this whole t2 minus t1. We need this time for it traveling further distance b from this point to this point. How much is the time required? If t1 is the time for this much traveling distance and t2 is for the whole traveling distance. I don't have anything given over here, just a velocity which is guiding me that you will have to go or you will have to solve this numerical using the formula of velocity, and the body is performing simple harmonic motion. So we have two formulas for velocity. One is at page number 112, where the formula is omega under root a square minus x square. Okay, the formula is omega under root a square minus x square, and the another formula of velocity at time t is a omega cos omega t plus phi. That is a omega cos omega t plus phi. So that becomes a omega just cos omega t. Phi is 0. Okay, when the particle is starting its HM or simple harmonic motion or its oscillation from mean position, we are considering it as it is starting from mean position, so it will take phi as 0. So these are the two formulas using which we can solve. Now we also have a distance over here. This b is nothing but our x displacement, because we have velocity at this point. We have velocity at this point, right? We have velocity for this point, which is v b under root 3, and we also have the displacement of it from mean position. So I can go with this formula first, that is v is equal to omega is nothing but 2 pi upon t under root a square, I don't have a, minus x. What is x? B. So b square. We have v with us, that is b under root 3 2 pi. What is t? That is 2 under root a square minus b square. This 2 gets cancelled. Okay, we can make it more easy. Before that, Okay, we can make this more easy. We can find out the formula for means we can find out the value of omega first, that is 2 pi upon t. So that is 2 pi, and what is t? See, I made a mistake. A particle period is given as 2 pi. Sorry, 2 pi upon 2 pi, and that is nothing but 1 radians per second. So directly you can write omega as 1 over here, or you can go with this. What I have done, I have taken omega as 2 pi upon t, and I am substituting t as over here. That is nothing but 2 pi. T is what? 2 pi. It is given in our question. T is 2 pi. So we'll substitute, and this will cancel. Either you can do it over here, or you can do it separately and directly write 1 over here. Okay, your wish. So what we have now, b root 3, I'll be taking square root over here, so that will become this, and a square minus b square over here, right? Then now b square under root 3 is nothing but 3, and I can take this minus b square over here, that will become plus b square, and that will give me a square, that is 4b square is equal to a square. Sorry for the horns. So a is square root of 4 and b square, that is nothing but 2b. So I got the amplitude for this simple harmonic motion. I got the amplitude, that is 2b. This is my amplitude. Sure. Next, what I can get, I got the amplitude. Next, I can use this formula. I have amplitude with me, I have omega with me, that is 1. Now see, if we would have not removed, again we would have to do this. We would have written at place of omega, that is 2 pi upon t, then we would have substituted the value of t, and then the same calculation. So instead of that, we can remove the value of omega first, and we could directly place the value of omega wherever it is required. Then cos omega value we know, and t we know the time. For this traveling b distance, the time is t1. So here we can find out value t1. What is that value? Because what we need t2 and t1. So t1 can be found out using this formula. So let's go with this formula. V is equal to, see, numericals are very easy, just you need to know the formulas. A omega cos omega t. A omega cos omega t. What is the velocity? At this point we know the velocity. At this point, which is marked with b, we know the velocity, that is b under root 3, and the time is t1. That is b under root 3. What is amplitude? We have just found the amplitude, that is nothing but 2b. So 2b, omega is 1, cos omega is 1, and this t is nothing but t1. So this b and this b gets cancelled. It is under root 3 upon 2 cos equal to cos of t1. Okay? Till now you have understood. Now what else we can do? Which value of cos gives me root 3 by 2? Which value of cos gives me root 3 by 2? We'll see over here. Which value of cos gives me root 3 by 2? That is 30 degree, which is pi by 6. We'll be taking it in radian form. So t1, so it is like this. Root 3 upon 2 is equal to cos. Which value of cos? Pi by 6. Yeah, just now I showed it to you. Cos 30 degrees pi by 6. Cos pi by 6 gives me root 3 by 2. So I have written cos pi by 6 gives me root 3 upon 2. Compare. So t1 is pi by 6. We have successfully got t1 or approached till t1. Now what else? Seconds. Now what else I want t2. So for t2, let's see, for t2 what can I do? For t2 I can use this formula, x is equal to a sine omega t plus phi. That will get converted into x is equal to, okay, hope it is visible to you now, x is equal to a sine omega t. Phi will be taking phi as 0 whenever it is mean position. So we have this now. X is what? Displacement. For which displacement we want? Where it is? For this whole displacement. For this whole displacement, what is x? B plus b? 2b? So x is 2b. What is a? 2b sine omega is 1. And what is t? For this bada wala displacement, t is t2. From mean till this point, from mean till this point, it is t2. So t2, 2b gets cancelled. We have 1 sine t2. For which value of sine we have 1? We have 1 for 90, that is pi by 2. So we have sine pi by 2 as 1. Compare. So t2 is nothing but pi by 2. Again we have successfully approached till pi by 2, that is t2. We want t2 minus t1, that is pi by 2 minus pi by 6. It is easy. Okay, 6 pi minus 2 pi upon 2 6 are 12, that is 4 pi upon 12, 4 1s are, 4 3s are, that is pi upon 3 seconds. So here we have obtained the time required for the particle to travel from this distance, to this distance. Okay, chalo. So I hope you all understood all the numericals of oscillation. I have uploaded all the numericals of oscillations in this channel of mine. So you all will find all my numericals for oscillation. Hope you write in the comment section how you all like the calculations of the numericals.